Hello, my name is Beth Dixon, and this is part 1 of a video based on Vicki Borlaug's PowerPoint presentation on the binomial distribution, and this is a summary of some of the other videos on the PowerPoints that I have done. I wish to thank again Ms. Borlaug for allowing me to use her PowerPoint to make this set of videos. We have an example we will use to summarize the concept of binomial distributions. A fair die is made for a children's game, and each side of the die has an animal on it. The animals are a shark, a polar bear, a pig, a mouse, a goose, and a lobster. As with any problem, I like to solve it like you eat an elephant, one bite at a time. So let's look at part A. If the die is rolled 20 times, find the probability that a lobster is rolled 2 times. First, does this problem meet the criteria of a binomial? Yes, there are 2 outcomes. A success is a lobster. Each trial is independent. Each roll of the die does not affect or is not affected by the previous roll. And third, there is a fixed number of trials. We have rolled the die 20 times. And the probability, since it's a 6-sided die, is 1 in 6 of getting a lobster. And this will remain constant each time we roll the die. So that meets the 4 criteria, and we have filled out most of our blanks. Let's fill out the last 2. The probability of failure will be 1 minus 1/6 or 5/6, and our x's will be 0 through 20. Here are our variables again. And let's create a chart. Notice we do not need to number our chart all the way down to 20, but we do want to kind of keep that setup and that visual in our mind. In this case, we're looking for the case that a lobster is rolled 2 times, so we are looking for exactly 2. And our formula, 20 is the total, C2 times 1/6, our probability of success, and 2, our number of successes, so that's 1/6 to the 2nd power, times 5/6, our probability of failures, raised to the 18th power, because if there are 20 total, minus 2 successes leaves us 18 failures. And that gives us 0.1982. Part B says, if the die is rolled 20 times, find the probability that a lobster is rolled at most 2 times. At most 2 times would be 2 or less. If you're still struggling with the at most or at least, do not forget that I do have a video on those phrases. Notice our formulas for each of those cases. The total of 20, choose 0 for x equals 0 successes. 1/6, the probability of success, raised to the 0 power, the number of successes, times 5/6, the probability of failure, raised to 20, the number of failures. 20 minus 0 gives us 20 failures. For x equals 1, that would be 20 choose 1 for 1 success, times 1/6, the probability of success, raised to the first power for 1 success, times 5/6, the probability of failure, raised to the 19th, because we have 20 minus 1, or 19 failures. And then the same formula that we had in the previous screen for our probability for x equals 2. We still have the 0.1982 for x equals 2. The probability that x equals 1 would be 0.1043. The probability that x equals 0 would be 0.0261. And since we're looking for x being 0 or 1 or 2, we add those three together and get 0.3286 as our answer. Part C says, if the die is rolled 20 times, find the probability that a lobster is rolled at least 2 times. At least means 2 or more, so we want to find the circled items here on the screen. That is a lot of numbers to find and add together. We could do that, but using the complement rule is more efficient. Notice that we have the answers from the 2 uncircled parts from our previous work. So we have the complement. Not only do we have the complement, we already know the answers to this from the problem that we just finished. So the 2 parts that we don't have, we'll fill in the formulas and their answers from our problem and work that we just finished. And if we add up the 2 uncircled parts, our complement, that will give us 0.1304. And our answer will be 1 minus the 0.1304. and gives us our answer of 0.8696. Part D. Let x be the number of times a lobster is rolled when the die is rolled a total of 80 times. Find the mean, variance, and standard deviation. Our directions tell us to find the mean, variance, and standard deviation. The mean is n times p, the variance is n times p times q, and the standard deviation is the square root of n times p times q. In this case, the probability of success and failure did not change, but this time the die was rolled a total of 80 times, and our n has changed to 80. The mean, therefore, is 80 times 1/6 n times p, and gives us 13.3333. Our variance is 80 times 1/6 times 5/6, and gives us 11.1111. Our standard deviation is the square root of n times p times q, which is the square root of 80 times 1/6 times 5/6, and gives us 3.3333. The last concept with binomials is to determine whether something is unusual or not. And because of the length of the video, I am going to pause here and I will pick up in the second part of this video. Thank you for watching.